Unit 4.4 Factoring Quadratic Expression. The objectives of this class is to find the common and binomial factors. I'll give you an example of binomial. For example, a plus 2. This is a binomial. Of quadratic expression, when you say quadratic expression, you have a square in one of those terms. For example, I'll give you this. And then to factor special quadratic expressions, such as, I'll give you another example, which is a squared minus 2 squared. These are special quadratic expressions. So in this unit, you're going to learn what factoring is. So what is factoring? And then the next thing you're going to learn is the greatest common factor, or we can call it the G greatest C common factor. The next concept you're going to learn is perfect square trinomial. I'll give you an example of what trinomial is. This is a trinomial. 3 terms. 1, 2, 3. 3 terms. Trinomials. 3 terms. The last concept you're going to learn in this unit is the difference of square, which is something like this. So what is factoring? Factoring is actually the reverse operation of the multiplication of two binomials. Take this as an example. This is a binomial and this is a binomial. So when you multiply by each other using the following method, you have x times x right here, which will give you this one, and then x times 2 right here, which will give you this one, and the next you're gonna do 4 times x, which give you this one, and the last operation is this one, which will give 4 times 2. So after you do this FOIL, you end up getting this trinomial, which is in this case x squared plus 6x plus 8. So factoring is FOIL in reverse. It means you try to find two binomials which multiply by each other will give you these trinomials. So these two are the factors of x squared plus 6x plus 8. This is what we call factoring. Let's start with some basic concepts in factoring. Before we start factoring, we have to recognize the form of quadratic trinomial expressions. It is a quadratic because it's a square right here. It's trinomial because you have 3 terms. And the next thing you have to pay attention is the value of a. In this case, when a is equal to positive 1 and negative 1, we can use the strategy of sum of factors. So now we have to pay attention to the c value and the b value. And since you have nothing in front of x squared, it means there's 1 right there. So you satisfy the criteria of using sum of factors strategy because a is equal to 1 this time. And the next thing you have to look at the factors of 20. The factors of 20 can be positive or negative 1, or positive negative 2, or positive negative 4, or positive negative 5, or positive negative 10, or positive negative 20. These are the factors of 20. It's right here. The next things you have to look at the sum of 2 of these factors which is going to be equal to 9. So if you try to combine the two factors here, the only sum of factors which will give you 9, this is the value of b, is 4 and 5. Once you find out this combination, you can write the expressions like this, because 4, I would say plus 4 and plus 5 are the factors of these trinomial expressions. So right now you have two binomial and the product is equal to this trinomial. Here is another example. This one is a little bit different from the one we did before because the value of a this time is a -1. All we need to do is to factor out -1 first by doing -1, of course, x squared, because -1 times x squared equal to -x squared. Now we have changed the sign here to -13x, because -1 times -13x will give you positive 13x, like the original expressions. And for the same reason, we're going to change the sign here to plus 12, because -1 times positive 12 will give you -12. We didn't change a thing compared to the original expression. It's the same thing, but we just changed the sign by doing the factoring of the -1 here. So right now you got a expressions which is the same as the one we did before. If you cover -1, don't look at the -1 right now, just look at this expression. It's the same thing as what we did in the last example, because right now the coefficient of x squared is +1. So we can apply the strategies of sum of factors again. So by doing this, we find out -1, -12 is what we have. So first, I will just write down x minus 1 and then x minus 12. But please don't forget you have a -1 sign in front of it. So you have put down negative right here. Or if you want, you can distribute the negative sign to the binomial by doing this. So you end up getting -x plus 1 times x minus 12. Or you can do the distributes to the second binomial by doing this again. So you have x minus 1 times -x plus 12. And by multiplying each other, you end up getting the same result of -x squared plus 13x minus 12 by either one of these two factors forms. The next concept we are going to learn is greatest common factor. For constant 2 and 4, the factors of 2 is 1 and 2. The factors 4 is 1, 2, and 4. Both have the common factors 1 and 2, but the greatest common factor, of course, is 2. So T is GCF of 2 and 4. For n cubed and say n squared, the factors of n cubed could be 1, n squared, or n cubed. For n squared, you have 1, n squared. The common factors for n cubed and n squared, of course, is these three. But the biggest one is n squared. Therefore, n squared is the greatest common factor of n cubed and n squared. Now let's see two more examples of how to make use of greatest common factor. So factor form is like this. This is what we call factor form, two factors multiplied by each other. So in this case, we make use of the greatest common factor of, say, the constant first, 6 and 9. So the factor for 6 is 1, 3, and 6. And factor for 9 is 1, 3, and 9. So the greatest common factor is 3. That's why I got 3 right here. So for n squared and n, the common factor for n squared is 1, n, and n squared. For n, of course, the factor is 1 and n. And the greatest common factor is n. So that's why you have n right here. So the common factor is 3n and 3n here. The reverse distribution, so we factor out 3n right here, and then look at that, it's plus right here, so 2n plus 3. The next example, it looks like it's a little bit big for like 4, 20, and 56, but they have a 4 as the greatest common factor. So you factor out 4. Now you got x squared plus 4 times 5x minus 4 times 14. So we factor 4 out, x squared plus 5x minus 14. That's what you got here. Once you come to here, we can make use of the sum of factors strategy, because the coefficient a right here is 1. We make use of the sum of factors of 14, which is 7 times negative 2 is equal to 14. And at the same time, 7 plus negative 2 is equal to 5, which is the b value here. Right now we know 7 and negative 2 is what we're going to pick. That's why you have x plus 7 here and x minus 2 here. Remember, when we learned the first strategy, the sum of factors, we can apply this strategy when we see a is equal to 1. What happens if right now we have an a value other than 1? Look at this example. Now we got 2 instead of 1. So what strategy we're going to use this time? We're going to use the AC strategy. The value of a here is 2, and the c value here is 12. So let me write down c equal to 12. So a times c, we got 24. We have to look at the factors of 24, which we have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 8, plus and minus 12, and the last one is plus and minus 24. We have to look for a combination of two of these factors which add up, again the sum of the vectors, equal to the p value 11 right here. So the only combination that we have is plus 8 plus 3, which add up to 11, and this is the p value. That's why you have this. The next step, you have to break it down to this. Look at 3 and 8 are the factors right here. So we're going to write down 2x squared plus 3x plus 8x plus 12. Okay, 8 plus 3 is 11 right here. And the next step is we have to do the greatest common factor. We group these together, and then we make use of the greatest common factor. In this case, x is the greatest common factor, so we have 2x plus 3. And then in here, the greatest common factor with 4. Then we have 2x plus 3. Now we get a common factor for these two expressions. we do the reverse distribution this time by changing it to, this is the common factor, we factor it out, 2x plus 3, and then x plus 4, and this is the answer. The next concept we're going to learn is perfect square trinomials. Again, trinomial, we talk about three terms. This is a trinomial. There's a special quality or property about this trinomial. It's because when you factor it out, remember, when we have a coefficient a right here as 1, we can use of the sum of the factors strategy to factor these things to make it a binomial expression. So we're going to use, of course, 5 and 5, because 5 plus 5 is equal to 10 here. You're going to have x plus 5 times x plus 5, and this time is interesting because you got the same binomial factor. You're going to end up having the x plus 5 square. Just like x times x, we have x squared. We call this particular trinomial as perfect square trinomial. Because of the special property of perfect square trinomial, we come up with this formula. When you have a plus b squared, you're going to have a squared plus 2ab plus b squared. I'll give you an example. If you have x plus 3 whole square, so a is equal to x, b equal to 3. According to formula, we can just expand it right away by saying a, which is x squared, plus 2, a is x, times b is 3, plus b squared, so 3 squared. So we end up have x squared plus 6x plus 9. Done. Same thing as a minus b whole square is equal to a squared minus 2ab. Remember, it's plus b squared right here. Same example, but this time change the sign. X minus 3 whole square is equal to x squared minus 2 times a is x, and b is 3, and plus b squared, so we got 3 squared, so we end up have x squared minus 6x plus 9. The last concept that we're going to learn in this unit is the difference, means minus, of two squares. Here's the formula. A squared minus b squared is the difference of two squares, which end up in factor form like this. I'll give you an example. If you have, say, x squared minus 3 squared, you're going to have x plus 3, x minus 3. We can factor these into factor form like this. If you have, say, 4x squared minus 3 squared, this time we have to do one more step, doing 2x whole square, because 2 squared is 4, x squared is x squared, 4x squared. So these are the same thing, minus 3 squared. So we have 2x plus 3 times 2x minus 3. But sometimes they will do something like that. Instead of giving you 3 squared, they say x squared minus 9. So you have to do another step by saying x squared minus 3 squared, and then you have x plus 3, x minus 3. Here's another example. We are going to use difference of two squares to factor these quadratic expressions. In this case, we have to change 25x squared into a perfect square first. In this case, we can do 5x whole square, because 5x whole square means 5 squared times x squared, which is 25x squared. And then we're going to change the 49 into 7 squared. Now we have 5x squared minus 7 squared. And then we make use of the difference of two square formula, and we end up have 5x plus 7 times 5x minus 7. Done.